Yes, am I audible? Vikrant, if you could just confirm.
Yeah.
Yeah, a very warm welcome to all attendees, and thank you for joining today's webinar on understanding opportunities and challenges in EV retrofitment. And we will have a focus on this on two vibrant regions, that is India and Africa. Before we move ahead, I would like to introduce you all to P-Manifold. So P-Manifold is a strategic management consulting firm working with a focus on e-mobility, new energy, transport, and hydrogen. Our work is into four domains: policy, strategy, engineering, and training. For policy, we support in developing energy and transport decarbonization roadmaps for countries. We work in developing climate transition plans, policy standards, help you with your techno-commercial feasibility, pre-feasibility studies in your country. As a part of the strategy, we help you all in having your go-to-market strategies for businesses that want to electric vehicles. As a part of our engineering service, we help in developing technical due diligence, in developing your products through model-based approach, help you in developing your EV validation processes, and we also give you an integration support. Our fourth is around the EVs training, where we have a subsidiary company, EV Acad, where we help you with EV technical courses. I will talk about it a little bit more detail in my subsequent slides. So yes, we are e-mobility focused company, and we have a growing impact. We have 300 plus consulting projects with 90 plus projects in e-mobility, and we are expanding and have expanded already across 42 plus countries. Our coverage in e-mobility is spread across different vehicle segments, different applications, value chain, and different areas as well. I would like to bring everyone's focus on EV systems engineering practice, which has become very, very critical nowadays. So under AVSC systems engineering practice, as I mentioned earlier, we support companies in conducting technical due diligence, doing their product assessment, product capacity and capability assessment, suitable, basically the market fit of the product for someone looking to invest into smaller companies. Go to market strategy, as I said, people who are into the IC world and want to transition into EV, then what kind of go to market strategy they need to adopt, helping them assess their competitive landscape. And again, the third portion is around supporting development of the products using model-based simulation techniques to help you with accurately producing your product that is fit for the vehicle integration in terms of electric vehicles. And this we spread across our EV components. We also have our subsidiary company, which we call it as EV Acad, which provides EV trainings and certifications globally. We have trainings across different different players in the EV ecosystem, from vehicle manufacturers, suppliers, to EV fleet operators, to national, provincial governments, development agencies, e-mobility entrepreneurs and investors, and students and faculties, of course. We have delivered 20 plus training programs in 40 plus countries, having around 5,000 plus learners globally. Yeah, that was all about P-Manifold that I just wanted to help you all understand. For the people who know us very well across the attendees, and there are some few new attendees whom I wanted to introduce P-Manifold. Coming back to our webinar, here's a quick overview of the EV retrofitment in India. Africa, we will have one of our speakers speaking elaborately around what is happening in Africa. So as the world is undergoing a transformative shift towards sustainable mobility, understanding opportunities and challenges in retrofitment with EVs becomes increasingly crucial. In both India and Africa, with diverse economic, social, and infrastructural factors that come into play, the potential of EV retrofitment offers a unique set of advantages. Some advantages, as I've listed here, they could be, EV retrofitment could act as a game changer by extending the lifespan of vehicles, reducing reliance on fossil fuels, and offering a cost alternative cost-effective alternative to purchasing new EVs. Apart from that, EV retrofitment, as we know, is being talked about as a environmental friendly solution, and also we could also say that it is more beneficial rather than having more congestion on the road with new EVs. Retrofitting your ICVs to electric would be helpful in reducing that. Given these benefits, there are also certain downsides which, if we believe that if it is worked upon, can help very well to scale up this EV retrofitment. And these are the initial cost of the EV retrofitment kit and lack of standardization. So a regulatory landscape somewhere is not that strong currently in India, and I suppose for Africa also is the same case. If we work around these challenges, EV retrofitment has a much greater potential. If you would go ahead and see the cost comparison for an electric four-wheeler, a new electric four-wheeler versus a new ICV versus a retrofitted, you would definitely see from the cost front they make more sense in terms of being a cheaper option. In India, currently there are zero point 0.9 million electric retrofitments that have happened in India in 2021. The market in India currently is, unorganized, with 80% of the market share is with the unorganized, but we are seeing a shift towards a more organized players, and most of them are startups. Now these startups are being acquired by some of the established players. So we would see going ahead like who are these players and how they are making a shift. Electric two-wheeler and three-wheeler are being spoken about as prominent vehicle segments where EV retrofitment makes more sense. But of course, people here in this, they are also figuring it out if electric four-wheelers and commercial vehicles would also make more sense. So a lot of evaluation and pilots are going on. Even for that matter, public transportation, buses and trucks are also being evaluated and studied under different studies that are going on in India. There are also type tests which are approved by ARI for EV retrofitment. So there is a AIS 123 Part 1 and 2 that is to certify the EV retrofitment kit. Apart from ARI, ICAT is also kind of authorizing certain EV retrofitment kit. And currently, these are the key players: Fox Motor, Eterio, GoGo A1, Loop Motor, Race Energy, 021. These are one of the key players who are working in the EV retrofitment. Overall, the broad understanding is that EV retrofitment is is an area of interest to a lot of people. So if you would just go ahead and look into what is happening around EV retrofitment, you would just see a lot of startups coming in this space. Government is also taking cognizance of EV retrofitment being a potential option in the EV revolution, and in that case, they are also bringing up certain investment incentives and policy measures for EV retrofitment. A clear example is the Delhi government and Andhra Pradesh government who are supporting EV retrofitment. And going forward, we believe that there would be a lot of government support and cognizance coming up again for EV retrofitment. This is the case even with Africa. In Africa as well, you would see a lot of players and startups have started coming up with EV retrofitment options, because these countries are basically using a lot of imported vehicles which are second hand, which are contributing to more pollution. So that space is also being explored in Africa. So we will go ahead and listen to our speakers from today's webinar on this very interesting webinar, where we would start and understand like what is the business case for EV retrofitment. Like people always talk about, why won't I go and purchase a new EV rather than retrofitting my EV. So let us hear from our speakers what are their point of view on this. Let us understand what are the technical challenges and measures to overcome them, which our OEMs in today's speaker slot, they would have done they have a hands-on experience in doing that. So they would help us understand what are the ground level challenges and what is the existing regulatory support that exists today in India and Africa as well. If and even if it exists or not, that we need to understand, and what is required, what is needed from the regulatory perspectives to drive the adoption of EV retrofitment. I would like to quickly introduce our speakers for today. We have Mr. Rani Srinivasan. He is the founder of 021 and former Tesla employee. 021 Renewable Energy Solutions is a Hyderabad-based firm that manufactures electric conversion kits for petrol and CNG auto rickshaws. These are ICAT authorized kit. ICAT is a testing certification organization in India. Then we have Mr. Stephen. Stephen is a mechatronic engineer currently doing masters at university at Stellenbosch. He has an experience of retrofitting minibuses with his professor, and I think currently they have also received good amount of funding. He looks forward to taking it to commercial scale in Africa. We have our third speaker, Mr. Vikrant Vaidya. He is a senior partner at P Manifold, leading the EVSC practice, EV Systems Engineering practice, and earned total experience of more than 20 plus in the automotive space and e-mobility. I welcome you all speakers and the audience, and let us start with our webinar and diving deep into this topic. So I would like to call upon Stephen and Vikrant if you would have any starting points for the audience, and then we'll go ahead and listen to Stephen and Mr. Rani subsequently.
Sure. Thanks, Yamini, for the introduction and setting the context. So I am sure what we are about to discuss will be of great interest to everyone. Yamini spoke about largely the Indian piece of it. So what we would like to do is invite Stephen to give a little bit more background on the African scenario, what have been his experiences. Let us hear him about it, and then we will get into the discussion, a moderated discussion with the panelists, and eventually we will go into Q&A. However, if you get a question, there is a chance that you might forget it, so it's good to put it on the chat box. There is a question box that you can put it in. So we will prioritize those first, and then get to live Q&A. So over to you, Stephen. I think you shared your screen, but it just went off again. You can reshare, please.
Thank you, Vikrant and Yamini, for that perfect introduction. So, yes, I believe you can see my screen now. I'm guessing you can see yourself and not the slideshow. Okay. Vikrant, if you can just, with your voice, confirm that you can see the slideshow.
Yeah, it's visible, full screen. Yeah.
Awesome, thank you. Yeah, so hello attendees and everyone. My name is Stefan Kok. I'm from the University of Stellenbosch in South Africa. So over the past 5 years, me and my professor, Professor Tinus Boysen from the Electric and Electronic Department of the University of Stellenbosch, has been investigating the retrofitting of public transportation vehicles in sub-Saharan Africa. In the 5-year study, we looked at the feasibility of how we can transition as a continent, but especially also as a country, into this new space. As you can see here, there's a minibus on the bottom left-hand corner produced by Toyota. The Toyota Hiace Fikile. It's locally manufactured here in South Africa. And on the right-hand side is a 65-seater manned bus. Now, if we look at the South African context, and I believe this might also be true for other countries in Africa, is we are exporting 63% of the vehicles that we manufacture locally. And 70% of these vehicles are exported to Europe. So this equates to around 4.3% of the total GDP of South Africa. Now, this is all internal combustion engine vehicles. So if you look at it from a job perspective, there's around 500,000 jobs locally that is at risk for 2035 deadline of Europe of not selling any internal combustion engine vehicles. Therefore, there's a massive transition taking place in Southern Africa, but also in the whole Africa, to start getting into the transition in order to supply these vehicles to different countries. So if we look at it from a country point of view, the biggest part for us is skill development. We're looking at carbon emissions, the reduction thereof, and getting affordable transportation, and then also accessible transportation. So we collaborated with the University of Oxford, and they made this quote saying that the vehicle capital cost is the key barrier for the uptake of electric vehicles, especially in sub-Saharan Africa, where drivers are usually very poor and can't afford very expensive electric vehicles. Therefore, affordable vehicles must be designed. And there's two ways in doing this. The first one is with local manufacturing, with sub-Saharan Africa specific electric vehicles. But the alternative option is retrofitting vehicles, which can even get the initial cost lower and which will make this transition even more affordable. So just from the minibus perspective, which is the specific vehicle that we approach to retrofit in our country, we can see that a new petrol Toyota taxi costs around 543,000 Rand. Then the diesel is 577. A new electric minibus is around 1.25 million Rands. And a retrofit electric minibus is 1 million Rand. So as you can see, it's almost double the price of a new petrol and diesel one, but this is with a single use case. So this is specifically the taxi that we retrofitted. But because it was the first one, it was obviously also a bit more expensive. But if we scale the process, we have calculated that we can get the cost of the retrofit minibus to 600,000 Rand. So that is half of a new electric minibus that we can import into South Africa. So if you look at this from a running cost point of view, we can see that the petrol and diesel taxis are above 300 Rand per 100 kilometers. And if you look at the new electric minibus, it's around 80 Rand. And then for the retrofit one is 120. The reason why the retrofit one is a bit more expensive is because of inefficiencies when we retrofit. The chassis and everything is a bit older components, therefore there is some power and losses during the process. However, when we look at the payback range, when you retrofit a single new electric minibus, then your payback period is around 220,000 kilometers. But if we can scale the process down, we're looking at a retrofit minibus, we can break even at 30,000 kilometers. Now, this is only on running costs. So if you add maintenance costs, it would even decrease more. But the big thing is why the whole of Africa is currently not retrofitting is these three problems. The first one is homogeneity. So it's the uniformity amongst the internal combustion engine vehicles. If you go into Kenya and to Rwanda, you will find that the minibuses over there is modified in such a manner that it's almost unusable when it comes to retrofitting. To require the necessary safety and standards, it's almost impossible with the modification of these vehicles. So this is a massive problem when it's come to the retrofitting scenario. Secondly is the homologation. Currently, South Africa specific has no set requirements or standards for the retrofitting case. We also have no way to get the roads publicly legal on the road. There's one way which I will present now. And then finally, scalability, which I believe is definitely an international problem. But yeah, if we quickly look at it, the taxis, 250,000 of them on the roads of South Africa. And because Toyota has supplied these taxis over all of these years, we are quite set that we get a uniform chassis design with not a lot of modifications. That's what makes it a unique vehicle in the South African space to retrofit, because they are very homogenic, and therefore we can more or less assure the safety and the requirements of the chassis that we retrofit. So what we quickly did is we designed a retrofit powertrain. We created a whole simulation model together with Oxford and the University of Reutlingen in Germany that can predict how the efficiency of the vehicles is going to look after we have retrofitted, to ensure that it is worthy to retrofit a vehicle. We've implemented in with a taxi, but we can reproduce this with any other vehicle. This is just a quick look of the components we chose. We used mostly Bosch components for the first retrofit, an inverter, controller, and finally we used battery cells. As you can see, this is a storage type of cell. Just because of availability in South Africa, this was the easiest cell to find, and it also has an aftermarket when it's done. So we quickly answered the question, should a manual transmission be used in a retrofit case? We actually found that in a simulation space, we have a 5% more efficient powertrain when we're using a manual transmission. However, this is on a perfect shifting model, and it also adds maintenance, and the driving experience is a bit awkward, and therefore we do not suggest it. However, this is definitely something that needs to be investigated into the future when we are retrofitting vehicles. So the biggest thing of retrofitting a minibus and any car in South Africa is to comply to the compulsory regulations. Now, the NRCS is our national regulatory for compulsory specifications, and there's two key considerations that needs to be taken into account. The first one is the gross vehicle mass, and the second one is the chassis. Because we are wanting to put the vehicles back on the road and use it for public transportation, we need to stay within the weight limits of every vehicle that we retrofit. This is for safety and ensure that the vehicle can be certified public for road use publicly. And then the chassis modifications, we're not allowed to cut, drill, or weld on the chassis. I believe this is also an international problem, which equates to a bolt-in kit when retrofitting. This is ever good for scalability, but important to note when designing a retrofit. The golden rule that we try to maintain is strive to maintain the vehicle as close as possible to its original physical condition and behavior. And this includes lights and everything except for the drivetrain itself. Now, to get the vehicle registered in South Africa, it's not as good. The reason, therefore, is we can't sell a retrofit vehicle. This places you in a position where an owner needs to give you a vehicle you retrofitted, and that owner then needs to go to the NRCS to achieve a letter of authority. With this letter of authority, one is able then to drive the vehicle publicly and make use thereof. However, this process takes around 2 months. And we are currently in talks with the government and the NRCS to try and get a standard process in place on how to register these vehicles and ensure safety for the people using them. Then we actually built the first prototype. I believe here is a quick look at the first prototype that we have finished around a month ago. There it is at the Cape Town beach. And that's how it looks. It's very maroon for the University of Stellenbosch. And yes, there's a quick overlook of how we build it. There in the left, we remove the engine. The right is the components for the taxi, which weighs around 50 kilograms compared to the 300 kilogram engine. There we have coupled it directly onto the differential gearbox. There's the power electronics. It's a bit over-engineered, which definitely in future iterations can be better. For the first prototype, we've placed the battery in the back of the taxi so that we can have access to it for in case something goes wrong. However, in future iterations, we're going to put it underneath. The quick specs of the vehicle, it can go 100 to 120 kilometers. It weighs 2,400 kilograms steer weight. It has 100 kilometers max speed. However, we were able to get it to 120 the other day. It has a 54 kilowatt hour battery pack, and then it has an efficiency of 0.49 kilowatt hour per kilometer. A few things that we've learned is it needs a cooling system because we are using storage battery type of cells. It's not used to working more than 1C for a long duration of time, which is very important to note when designing a retrofit. The charging system, because of voltage issues, we can only charge at 7 kilowatt. However, the system does include a 22 kilowatt charger, but we need to increase the voltage in the battery pack. Then the interconnections, because of safety, we used a lot of confusers and contactors, but this can also be simplified. And then battery position, it needs to go underneath the vehicle in future iterations. And finally, software and controllability is always something we can improve on. The braking system is a big question in South Africa, and I think one of the most fears when retrofitting in Africa, and it needs to be addressed. Firstly, this system does include regenerative braking, therefore it recoups the energy when it slows down. It does have the original vacuum assisted braking. One, however, needs to put an electronic vacuum brake pump to insist this and not the vacuum of the engine anymore, and it still has the original handbrake. So our contributions with this prototype, as you can see, there is an article written exactly how we built the whole vehicle from data, tracking an internal combustion engine taxi and converting it and also validating it with tests. So one can just read through that to understand it all. We have established the proof that the transition in South Africa, retrofitting is a very good use case. We have established a roadmap how to do it, and we validated all our simulations. Currently, we are busy with a 65-seater bus, which will be hopefully finished at the beginning of next year or the end of this year. We have started a retrofitting company, which will start developing vehicles in this year already, and we're going to move over to a small, we call it a bakkie, but I think it's a pickup truck in the next few months. So this is the 65-seater bus, which we are in collaboration with Golden Arrow with. We're going to start retrofitting about 1,200 of these buses, which is very good for scalability and also homogeneity in the next 2 years. This is the small pickup truck that we will be retrofitting as well. And then very important for the South African and African use case is the transition needs to happen now. And we truly believe as a university, but also from our studies, that retrofitting is the start. However, we do believe the new electric public transportation system is the future. However, for cost, for the driver, and for the energy crisis that we are struggling with here in Africa, we believe retrofitting is the optimal solution in this transitioning phase. Thank you. That is it from my side on the presentation.
Thanks a lot, Stephen. Very interesting and glad to see the progress that you have already made. You have already committed to scaling up on those three, at least what I saw, the pickup, the long bus and the minibus. Yeah. I think Mr. Ali, you can hear us on the forum itself now, I think. So
Yeah,
I would
able
like
to
to
hear you.
invite. Hi, hi. So I would like to first probably invite your comments on what you saw from Stephen, primarily because you are a little bit few steps ahead. You have already achieved the scaling to a certain extent, and you probably can also look at the challenges that Stephen talked about and probably share your thoughts on those. We can start with that. You may.
Definitely. Thanks, Vikrant. Good to know. Thanks, Stephen, for the heads up or the insight about the projects. I think you have nailed, and then whatever you said, that what you have learned is absolutely perfect. Because according to the World Economic Forum, India and in another 40 countries cannot achieve a complete electrification, not even complete, forget about complete, but even 30% of electrification unless until we convert the existing vehicles. For the simple reason is, even we don't, at least in India, we don't have a perfect scrap policy. So while scrapping, you emit a lot of carbon, and then as Yamini said in the introductory call, by introducing a new vehicle, you are not addressing the current carbon emission vehicles. You're only curtailing and the future vehicles, but not the current one which is already existing. It's almost 2.96 kgs of carbon gets emitted per 1 liter of diesel. So now imagine, everyone says CNG is little green and all, but trust me, it's just 1.96 kgs of carbon gets emitted. So that's where the challenge lies. The best way is a perfect bridge for getting into an electric is a conversion kit. That way, you are not emitting a lot of carbon in manufacturing so many vehicles versus scrapping so many vehicles. It's a perfect gap, I should say. And then, according to the World Economic Forum, they have given a very good report on that, at least in Indian scenario, and then some countries of the Africa as well. So I think you're in a perfect space, and we do have a lot of requirements for the 9 meters and 12 meters buses. In fact, we have recently gone through some of the what do you call we did some of the projects actually study in one of the, and then we are also trying to do one particular project for cement factories. They have more than 1,000 vehicles running, and then one of the CEO met me in one of the seminars, and then they were so much interested. So we are also working on the project with them as well. So anything for a 30-ton truck, haulage truck, is also welcomed. We do have, I think we can also see how we can share our thoughts and then synergize in order to complete those projects. And that's about the four-wheeler. And in fact, I just wanted to give you also insight that a lot of other state governments in the country also go for a scrapping of the vehicles after 10 years. But I think we can, a conversion kit will be a good solution for them. And as far as the 021 is concerned, coming back to the three-wheeler, yeah, we have done a lot of extensive studies, but it takes a little time in India to penetrate. But we did lot of studies. We have 4.8, that is 48 million auto rickshaws in India, 4.8 crores of Indian rickshaws. India is the highest three-wheeler manufacturers in the world, and one fundamental principle is, if India adopts, 40 other countries can adopt blindly. You don't need any modifications in that vehicle. So today, current scenario, Bajaj manufactures more than 7 to 8 lakh vehicles per annum. So, and then out of them, 30 to 35% are export. So you can imagine all the other countries who are using the three-wheeler. The beauty of the three-wheeler conversion is just take less than 5 hours to convert the vehicle. That means a daily bread earner, he don't even have to waste his whole day. He just gives us, and then we will convert in just 4.5 hours time. That can be Why am I saying is, keeping in view, three-wheeler is one of the most economic commuting system. We can make it a more economic, and then an electric driving, driving comfort. Because one major challenge in the electric three-wheeler is the ergonomics has not been considered well. Unfortunately, today 52% of the auto drivers are suffering with various ailments, spondylitis, arthritis, and all these challenges. In a three-wheeler, on an average, an auto driver changes his gear for 1300 times in a day. Imagine what the toll which takes on the on your wrist, you know. And I'm sure you, I don't know, you wouldn't have got an opportunity to sit, but it's a flat seat. It's very different, difficult for an auto driver, because it takes a toll on your shoulders, and then all the other challenges. So we have tried to overcome that because of vibration, because on an average the driver spends around 10 to 12 hours a day. The amount of vibration which he gets because of the engine is, trust me, it's unimaginable. We are trying to do this. We have, first of all, we can't sell this as a commodity, or an, it's just an not a counter sale kind of a thing. You have to sell it as a concept. We wanted to educate them. We wanted to say you can very well use, because a lot of sentiments are attached to that vehicle. They say, sir, I can't dispose. Fair enough, you can convert this vehicle. So these kind of things we are also requesting a lot of organizations to arrange. And then today we have an ASCII, which is a staff college, which is the administrative staff college people. They came forward, and then now they are having a boot camp in order to do a boot camp for them to do knowledge transfer, saying that what is the advantages of the electric conversion kit and all those stuff. So these are all those challenges which we have faced. And then see, we are here by choice, not by chance. So we know the challenges are well anticipated. I did not expect that it is going to be a smooth ride, definitely not. So we prepared well. Of course we get more challenges than what we anticipate, but the fact is, you have a huge demand, humongous amount of demand is there. The only thing is your perseverance and persistence, and then how well are we in order to take this concept. Why I always appreciate and then take out my time, and then I have always a soft corner, or you can say that I'm inclined, is if someone says anything retrofit, I think I'll be the first person to say yes. Because through you are the people like Vikrant, and then your team is doing a good job, and then you can take this point to the many other people. Maybe I'm unable to reach to the, you can't expect a fish to climb a tree. We are good at this, but maybe we are failing at a marketing level, or how we can take this point of, maybe they are really good. So with the help of them, we can take it forward to, or take it to the people. See, this is what I wanted to just say as a preamble, and then about a whole journey of 021. I think I would like to specific, if you have any questions, then I'll just take a pause and then ask you if you have any questions. I'll be more than glad to answer this, Vikrant.
Sure. Thanks a lot, Shlani. And it brings up a very interesting thing. If I may direct this as a question to Stephen, but just a thing to ponder. We do this total cost of ownership studies based on the upfront purchase cost and also the operating cost. However, what we have seen is happening is uh, for particularly for productivity vehicles, nobody purchases it cash down, right? It's always finance. So in a sense, even the capex is also an opex. The capital expenditure is also eventually EMI or something of that sort. So and there, what we have seen as a challenge is uh, uh, the lending people, the financiers, they are not yet on board. They are having those concerns in terms of the new technology. There is always the talk of battery getting replaced before the vehicle is due scrappage or replacement, and all of these talks. So, Stephen, have you looked upon this, or have you encountered these challenges in terms of how these vehicles will get financed? are you working on? So Mr. Ramani talked about awareness programs for the driver owner kind of people for the vehicle, bring them in and get converted. But at the same time, even the conversion would probably need financing of some sort. So have you looked upon that? Have you encountered these challenges here?
Yes, I think Ronnie would agree with me. If you're retrofitting, you have to deal with this problem too, because it goes hand in hand. The weird thing as you speak, like the technical part of it is actually not the difficult part. We are at a stage where the technology is there and we can implement it into the vehicles, but it's the structuring thereof. The government, especially in sub-Saharan Africa, they're looking at this and quite frankly, they don't understand, because in our heads, especially here with the local people, when they hear electric vehicle, they hear complexity, they hear difficulty, and they see an expensive thing, something that is out of their reach. So it definitely is something that we have encountered. So we have two entities, the Development Bank of Southern Africa, and also the IDC, which is the institution development of something. So they do have programs in which we incentivize drivers to buy these vehicles under either a loan agreement or a lease agreement, in which they can pay off the vehicle over time, which is very, how can I say, attractive to them. However, the problem is with retrofitting, it comes back to data. The ADC and the Development Bank, they are not eager to give the money if we can't prove the lifespan of the vehicle. So you can run as many simulations as we did, and we did all the research possible to try and convince these people. However, at the end of the day, it's ground data and tracking that proves the concept, that proves the prototype. So I think for us, the biggest challenge is to convince the initial funders to help us to develop the product so that we can start tracking the vehicle, so that we can start proving it within operational scenarios, and then come back to them with the data and say, okay, this is how it is. Because in that manner, you will be able to prove it. So we're actually also working with a company in Kenya called Rome Electric. And there, the scenario is a lot different to South Africa. They are more focused on the motorcycles and the buses. But the motorcycles, they called it the boda bodas. So the boda bodas, what they do there actually is the driver don't own the battery of the motorcycles. So what they basically do is the company owns the batteries, and that is usually through a development bank or whatever the case is in Kenya. And then the driver only takes the motorcycle from that company, drives it around, and basically rents the battery from that company. And that is very incentive to the drivers. We've calculated just from a Kenyan perspective, they save around 10,000 Rand a month. So that is now in South African Rand. I don't know how to translate it to your currency, but that is that's exponentially a lot more than they are earning currently. So yes, we have been dealing with it, but I do think in South Africa, it's all about the perception currently, and especially because we have companies like Mercedes and all of them currently transitioning to new electric vehicles. The government is currently more focused, sadly, on policy for new electric vehicles rather than retrofitting. So this is also a key barrier for us to get financing for retrofitting, because most of the finances currently is allocated to producing new electric vehicles.
Okay, sure. Yeah, thanks for that lead in also, because I was also about to bring in this point. One is, of course, we talked about having the financiers on board, and we will have to compete with the new manufactured vehicles as well. And typically, the OEMs will not be interested in retrofitting other than prototyping. I'm pretty sure they would be interested in selling the new vehicle. So how does so now in India, for instance, we do have automotive industry standard, as Yamini displayed it, AIS 123. But how much of it is really supporting the stream? And secondly, you also briefly talked about battery as a service or swappable battery or battery on lease kind of model. And battery does add a significant amount of cost. In fact, lot of times if you take the battery out of the bill of materials, your cost parity is already there for the vehicle. So I would like to hear also from Mr. Rani, uh, how is this panning up in terms of sale of the kits? Now, if somebody is looking at a new vehicle, new electric vehicle, or even IC engine vehicle versus a old vehicle purchased at, I don't know, 20, 30, 40% of the new cost, and then the retrofitment kit. So how does this pan up, and how favorable or how supporting the current AIS 123 is? Does it add further compliances which make the product costly, or what are your views on it, Mr. Ran?
See, AIS 123 Part 3 is just a one-time activity. So I don't think that needs to be considered, honestly speaking. Okay, it asks for a couple of tests more, that's fine. But the fundamental challenge here in India is all our policies are aligned towards a new vehicle. If you see the FAME 1, when we started in 2019, under FAME 1 subsidy, there was a subsidy for the conversion kit also. But because of the various pressures from the OEM or whatever the things are, they have removed it from this thing. As you rightly said, the OEMs will never get into a conversion kit, because why will they cannibalize their own product? They won't. So number one, so the conversion kit will have a challenges from all corners. Number one is from their own OEMs itself. So they say that they'll pressurize, and then the FAME subsidy is not been extended to conversion kit. Second challenge is the GST. For the GST, the new vehicles GST is 5%, whereas the conversion kit they are charging 18%. So that is again a disparity of 13%, which is and as far as the cost difference is concerned, minimum to minimum 1.25 lakh rupees is the bare minimum difference between new vehicle and an old vehicle. A new vehicle versus conversion kit. Why? Your motor capacity remains same, your battery capacity remains same. The manufacturing of the shell, that's a whole vehicle including tire, everything, will cost them around 1 lakh to 1,25,000 rupees. If you compare apple to apple, a new for manufacturing a new vehicle, it's around 1,25,000 to 1,50,000 rupees is a considerable difference. Whereas I'll give you a classic example. Today's a new vehicle is costing around 3,25,000 rupees. The conversion kit what we are giving is around 1,60,000 to 1,70,000 rupees. So 1,50,000 is a considerable difference. So one more challenge is a finance. As Stephen has rightly said, the buck stops here. We all technology driven, market demand, everything. But for financiers, neither he thinks about a technology as actually, I mean, I shouldn't say this, it's a very big word, it's not a right word, but I just wanted to say it on the right order. For financiers and auto drivers, for them what matters is how much am I saving. They hardly cares about an environment or anything else, because we have interacted with ADB, Asian Development Bank. We gave a demo. Actually, I really appreciate them. They came forward. We have spent almost 6 months time to get into the nitty-gritties of each and every auto by area, and then they wanted to float a target or some agreement with the ESL and all. Unfortunately, it didn't go well. So they said, but they came forward to us saying that Rani, whenever you do a project anywhere, we are ready to help you out, because they wanted to help. They also of late realized that this conversion kit is a right product, but the problem is who owns it. Whether the battery is owned by, do they wanted to finance the owner? So who is owning the battery, who is owning the motor and controller, who is owning the the vehicle? So here you have a three fathers for them. Now who will claim what? So this is where we have to draw a line. What I am trying to suggest is the swappable battery or energy as a service, as long as the running cost is not coming down considerably, the auto driver is not inclined to do it. See, for him the incentive is how much am I saving on a daily basis. he, at this level, it is too much for us to expect them to that he cares about an environment and all those. Trust me, it's not going to happen. At least in India, I can say, where most of the people are below poverty line, he says, sir, no, you take care of it. No? Why are you bothering us or the environmental? So we have come up with a picture, or we have come up with a scheme where it's a win-win situation for everyone. So who are all the stakeholders here? The auto driver is a stakeholder. He should earn money more. The financer who should get money back very safely. We as a retrofitter should also can earn our money back, and then battery as a swapping station. What we are suggesting is, if you include a swapping stations, again the infrastructure cost is more, and then running per kilometer is more. Rather, you give a big battery, at a big battery, in a day he runs on an average 125 150 kilometers. See, first of all, this swapping concept is nowhere in the world except the Asian countries on a two-wheeler, and then India, who are talking about it. No car is looking for a swapper, no truck is looking for a swapping, no bus is looking for a traffic. No, why should we a three-wheeler is looking for thing? Now, for example, you see a e-rickshaw, which is sold around 40 to 45,000 vehicles are getting sold per month. That means it's around 4.5 lakh e-rickshaws are sold in India. Now, does anyone bothered about where are they getting charged? They'll figure it out, don't worry, because they have a home chargers, they are the places where they charge and all. What my suggestion would be, or rather our take would be, we have been advocating this, a financer will get his finance money back within 18 months time. The driver today who is spending around 700 to 750 to 800 rupees will spend only 400 rupees, where he will save at least 200 to 250 rupees on a very high level. That means, which is it's almost 25% more in his income. And then his health is very much well taken care, and financer will get his money back in 18 months, and then services and everything will be taken care by the OEMs, and then battery is safe because he is paying money on this thing. And then we have all these IoTs and everything, no one can do anything with that. And then we also have a software where whenever he charges money, the money can get deducted. So so this is the option. These are all the learnings for us also. We did not have these options when we started. Over a period of time, we came up with these thoughts. Today we became kind of a solution which will satisfy the financiers, which will satisfy the driver, which will satisfy the government and everyone, that we are not emitting carbon. So for your solution, can we really scrap 4.8 crores of auto rickshaws in Indian roads and then get all the new one? Trust me, it's not possible. Can we convert? Yes, this can be done.
Great,
I
great.
think
That last part
elaborate.
is sure, sure. Go ahead. Go ahead.
I said I went into a very detailed, elaborately. I mean, I don't know. You may be, just kindly bear with me, because it's so much there. You have to give you something. You have to filter a lot.
No, no, absolutely. That's why the format is a discussion format rather than one way. And in the discussions, it actually we seek the specific elaboration anyway. So absolutely no problem. Yeah. And I was just pausing on your last sentence, that is it possible to how quickly, or if I may slightly rephrase it, how quickly do you expect 4.8 crore people to adopt a new electric vehicle, versus how quickly you can expect them to adopt the electric vehicle through retrofitment? And that really is a very powerful statement, right? If you expect this to be done urgently, if you expect this to be the immediate solution, right? uh, uh, and lot of times what happens is people are also looking to bet on something of this sort. First of all, get their confidence high before actually migrating full scale, and thinking about new vehicles as well, right? We have, I don't know about South Africa, Stephen, but we have a culture that if we are buying our first car, a lot of people prefer to buy a used car, learn the driving, get the confidence, and then go for a new car, brand new car. So that also is kind of what tells me that this is where you have to start and do that transition as a psychological transition first. rather than the technology and all other things. I think we have questions coming in as we were speaking. So let me take some of those, and in between, if it develops further into a conversation, we will look at that. So we have first question is for Stephen. What modifications are done on the Toyotas in East Africa that would make them hard or impossible to retrofit, as you were talking about the minibuses, right? So if you can elaborate on that.
Yes, so in Kenya and East Africa, the modifications they do is actually not on a Toyota. The Toyota is quite specific to the South African use case. So the not the the Mabatus is what they call it in Kenya. And it's usually a Isuzu minibus. It can hold around 40 to 50 people, but that I might be corrected on. So the type of modifications they do, it's actually amazing to see. They almost make it into these party buses. So each and every driver tries to make their own bus more extravagant than the one next to them. So what they do is they cut down the whole body of it. They go into the chassis. They try to extend some of the minibuses. Some of them they shorten. They insert speakers, so they draw into the chassis to mount certain things. So there's a lot of things like that. And also, if we look at the road qualities in Africa, the chances that you are getting a chassis that has not yet been fixed, not yet been welded on, not yet been repurposed during its lifespan to the point now where we want to take it and retrofit it again. At that point, the safety concerns surrounding that chassis can't be, you can try and fix it, but in a South African point of view, then that's a lot more homologation steps that needs to take place. The moment you touch the chassis with Toyota or Isuzu or whoever has produced, you're starting to get into problems of who's taking up the responsibility, as Ronnie quite clearly said. So that's a big challenge why retrofitting, the company Rome specifically, they started with retrofitting minibuses in Kenya, but they moved over to building new electric buses locally in Kenya for this reason, that they couldn't guarantee the safeties of the chassis.
Mm-hmm. Yeah, yeah. That kind of reminds me of even in India, buses as well as trucks. They are preferred to be bought as chassis only, even the new ones, and then they can put up the load bodies based on how they want to use the truck. Even the buses, the staff buses, the shuttles, all the private buses, I would say, those are custom built often. There are a lot of coach builders around, so I can imagine. But interestingly, there is a bodybuilding standard as well, a regulatory standard as well, that has to be complied with. I'm not so sure how much it is complied with on ground, because lot of this stuff is also unorganized. Yeah, uh, probably if the government feels they can start imposing those or enforcing those standards more. Just on that, one thing I'd like to check with both of you, your thoughts on it very quickly, is in terms of assuring the safety. Now, I'm sure the smaller vehicles, 48 volt, 60 volt systems may not be a big deal, but when you talk about LCVs, mini buses, long buses, you are definitely talking about a 100 volt plus or 200 volt plus platform. In retrofitment, how do you ensure or assure, in fact, not ensure, but assure both the regulatory authorities as well as the customers that this is still equally, if not more safe vehicle? Maybe Rani, if you can go first, and then I will go to Stephen.
See, as far as the three-wheeler is concerned, it's just a 48 volt. However, even that is also quite sufficient for someone to have any accidents. See, there are 3-4 things which are very critical as per the AS 123 part 3. All these retrofitment centers which we are going to set up across the country, because you can't have a one specific place that all our vehicles will come to that place. No, we need to have a retrofitment centers at its respective places all over spread across the country. We need to ensure that some of the safety measures has to be acquired. There's no doubt about it. Two areas which are very critical for us as far as the battery manufacturing is concerned, we are not encouraging any battery manufacturer unless and until he is completely certified as per the latest certification, and their BMS cuts off. Now we are practically checking. And then what happens is, today, with the help of these scanners, with the help of this RFD IDs of the cells, you can literally monitor your cells, and then those monitoring cells also will help us if someone is a faulty one is causing a problem and all out of the back. What we are also going ahead is, at least I know we are today in our company, we have one person, Dr. Raj R. Sharma, who is a MTech, and then he is a gold medalist from IIT Chennai. He is helping us out. So we are also planning to go ahead in next 7 to 8 months. We will have a health monitoring system or a vehicle the cell monitoring system, which is driven at the district level, so that he monitors for across in their own areas. But practically speaking, can we monitor this thousands and lakhs of cells? Not possible. Everyone, when it comes out, at that time itself, you need to have a quality check, perfectly check done, and then do it. And then randomly we need to do. So these are all the areas which we are doing. And then we are also having one sensors, because what happens is everyone blames the battery, but there is also the culprit is about the charger. The cable which is going from the charging cable is also a culprit which is unnoticed. And one more area which is like the amount of power which has been drawn from the motor. So these are all the areas which we have actually put some sensors. We are requesting our OEMs to take that extra care, because from that extra care to a negligence, the difference is very minimal. What it needs is more than the money. It needs your involvement, your commitment to that safety is what matters the most. So at this moment of time, touchwood, we are taking all that, and then that has been always at the back of the mind, which bothers us. So we have been ensuring, because in India, once it goes out of your premises, controlling quality is always a challenge. So we are time and again we are keep telling that it's not just something that you do it in a roadside thing without anything. So we are avoiding as much as we can. But yes, this has always been at the background, and we take that corrective actions, Vikrant.
Sure,
Yes,
great,
Vikrant,
and thanks.
think I can
Stephen,
jump in here.
yeah, please go ahead.
Awesome. Thank you, Ronnie. Yeah, I think exactly the same. So, I mean, it is, you're not the OEM, you're not Toyota, you're not whoever. So you are working on a vehicle that is guaranteed safety in from the point of view of the drivers or whoever's using the vehicle, and how you're retrofitting it. So that's why the golden rule is so important, to keep everything as close as possible the same. And just to that question too of how we address it between the manufacturers and OEMs, I think safety also gets into. That's why there's a long homologation process that needs to take place. So every single thing we put into the taxis, now with the taxi, we are working with 250 volt. And with the bus, we are increasing it up to 400 volt. So that's a deadly voltage, which needs to be secure. Otherwise, you're going to have a lot of problems. So what we're trying to do is, well, not trying, what we are doing is we're monitoring each and every cell individually, as Ronnie has pointed out towards. We are monitoring each and every cell with their switch on to every cell. We also do live tracking to try and make sure that we are constantly live aware of every vehicle's condition, the battery, and so on. And if there is a fault, which has not yet happened, but if there is a fault, then you are able to switch off the vehicle and trip the we call it dev switches, the isolators, to ensure that nothing goes wrong in that case. But as Ronnie mentioned, there is limits set everywhere through the vehicle. It's almost like programming a small Arduino. You can set so many safety limits into the retrofit vehicle that it's almost, I don't want to say impossible, it's always possible, and that's why you take the necessary measures to make sure it doesn't happen. But for a battery to really run away, if it's designed correctly and you use the right safety components and fuses within the system, it should not ever get to the point where we would see the firmware runaway happening or something like that. But the homologation process in South Africa, just to give you an idea, if you want to do an electric bus here, it's going to take around 12 to 15 months to go through all the safety and specification standards. And if it meets all those standards and specifications, then you can, no, I don't want to say at the same level as Toyota, say that it's the same safety, but more or less I would be confident because I'm the one building it, but obviously it differs from what point of view you're looking, but the safety should not then be an issue if you meet all that requirements.
Great, 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 great. Thanks. Looking at a few more questions, I would like to combine a couple of them. One speaks about the additional weight that comes because of the battery. So electric vehicles tend to be heavier because of the battery packs, and also the fact that those are typically used vehicles. So how do we ensure that the impact of this additional mass on the vehicle chassis, so to speak, or the body, depending upon what kind of vehicle or structure it is? How do we ensure that, and then how do we also ensure that the used chassis is it roadworthy to get this new lease of life through retrofitment? Maybe Stephen, if you can start off, if you have given thoughts around that, and then we'll come to Rani as well.
Sorry, Vikrant, you quickly broke up. Can you just shorten the question quickly that I can just hear what you said?
Sure, sure. So one part is because the vehicle you are retrofitting is already a used one. How do we ensure the roadworthiness of this with the new life it will get through retrofitment? And secondly, what is the impact on this as well as other aspects of the battery mass, the additional battery mass that comes on the chassis?
Yes. Okay. Yeah. So the way is, once again, you work through the necessary road and safety. So in South Africa, there is quite a proper system in place to ensure that a vehicle is roadworthy and that it can drive safely on the road. It is a bit difficult when it comes to operating buses and minibuses, where you have to transport more than a certain amount of people, which does increase the difficulty, but also then ensures the safety more and more. So I think the interesting thing to note is, because we are using all the vehicles, we have found that most probably the new electric drivetrain that we are inputting into the vehicle is actually going to outlast that of the chassis. So I want to sort of switch the mindset to say we do need to monitor the electric drivetrain, and it's important to make sure that it's maintained and all those things. But more so, we also need to look at the older chassis even more during that time, because we predict that the battery and the motor itself is definitely going to outlast the chassis, which is also then a case where it also adds to the scalability of the product, because then when I am needed to maintain or to remove certain or replace certain components, well, then I'm going back to the standard, let's say Toyota components, that's already flooded in the country, and that already most of the local mechanics or whoever exactly knows how to work. So I think, yes, the safety, the roadworthiness is a bit of a problem to do it on scale. We are able to do it individually. In South Africa specific, sadly, you can't on it. So you as an accelerator for vehicle, yet we are working, owner need to own the vehicle, and you need to basically qualify to use it on a personal level. So, but that process we assist you with, and it's with the Traffic Department of South Africa, and they assure the safety at the end of the day.
Okay.
So
Yeah.
do you want
Rani, would you like to comment on? Yeah, please go ahead.
for the three-wheeler, the vehicle, engine and the gearbox weight is approximately 76 kgs, something around anything between 60 to 75 kgs. So when you are replacing with the motor, the gearbox, and the around 3 to 4 kgs of your petrol tank, so put together everything comes around 76 to 78 kgs. The motor and controller with the gearbox will weight you around 31 kgs, where when we put a 100 Ah battery pack, it is around 48 kgs. That's out. But 100 Ah will not be sufficient. Even if we put 200 Ah, which is a 10 kilowatt battery, then the weight increases by another 45 to 50 kgs. However, first condition for conversion is your vehicle should get a fitness certificate, number one. So once you get a fitness certificate, that means this vehicle is worthy to convert it. So number two, that is why when you converted a vehicle, the speed is limited to 45 kilometers. and you know the speed and the weight is directly proportional to the usage and then capabilities of that particular conversion kit. Number two, these are the major factors which we do. And also one more advantage is we are also giving a 3 years warranty on our components which we have replaced it, not on the existing like a tire and all this, no mechanical parts we don't touch that.
Right.
So converted vehicle, the motor control and these things, we are giving a 3 years of warranty including the battery pack, so that way they are safe and then assumed. Of course the chassis part, it take the weight? Yes, it will take the weight.
Okay. Okay. Sure. Then I see a couple of questions which we covered in our previous discussion as well. Are there any concerns that you have seen for insurance as well? So now we talked about financing, but there is one more stakeholder, vehicle insurance. So how does that pan up in your experience?
I can take that point. Without insurance,
If you can start. Sure.
without insurance, you don't get an insurance. Without insurance, the vehicle don't get financed. So we are getting, I mean, we got an insurance for our conversion vehicle kit also. So to answer your
Okay, so
point,
you take that.
yeah, without
Hmm.
insurance, it cannot run on the road. So insurance is mandatory, and then we get insurance for our converted vehicle.
Okay, okay, and you have those tie-ups. You have instilled that confidence, like we talked about in the finances. The same confidence would be there for the insurer as well, for them to provide the insurance for these retrofitted electric vehicles. So we already have a challenge for electric vehicles, but now it's a retrofit electric vehicles. It's more of the risk bells that ring in there. So it has been okay with you as of now, Rani?
Yeah, so far at least some people have taken some kind of what you call a very brave step, I would say. Out of 10 100 people, at least a couple of people have come forward and then they have given us insurance. As far as the financer is concerned, through your webinar, I would like to request them, what would be their apprehension? Is that the battery? Anyway, battery you are getting 3 years warranty. So you have a complete assurance from your battery manufacturer. From the motor and controller and then conversion kit is concerned, we are giving you a, we says if anything goes wrong, we are buying back you at the free of cost, right? What else do they need? And then nothing else will happen to the shell. So it's just an apprehension. You see, opinions can be changed, perceptions cannot. It's just a perception. So nothing to worry, I mean, did anyone thought of industrial insurance or something 25 30 years back? No, now it has evolved. So similarly, conversion kit concept has come just couple of years back, few years back rather. So I think I'm sure people are quite smart enough to know all these tech savvy at company, all this fintech, typical finance people have become a fintech companies. So they are also financing on a technical basis. So I think I'm sure they are also can understand this. And we are as an original OEMs are giving them an assurance. And we even give them an
Right.
IoT, can track why a driver is not driving from past 120 hours. They can track. So they can talk to him saying that, Baba, what happened to you? Why are you not driving? He says, I'm not well. Okay, would you like to give it on a rent? We can give that vehicle on a rent. Anyway, 70% of our vehicles are running on a rent. Only 30% are DCOs, that is driver come owners. So we have all ways of, I know they are not, we are not talking about an idealistic condition, but extreme conditions also can be met.
Right, right, right. Yeah, the availability of data and tracking of the vehicle is something which has which was born with this technology, right? We almost every electric vehicle has that. So yeah, that's
That's,
something which is worth understanding. Right? It reduces your risk.
that's why we always say time and technology changes many. It brings a revolution. So
Right,
this is done.
right, right, right. Yeah, Stephen, there is a question for you specifically in terms of the overall African market. In fact, uh, uh, not just the South Africa or the Sub-Saharan Africa, entire African market by and large is heavy on used vehicles. And there the governments also struggle to get the used vehicles comply with certain norms, because they are first of all used vehicles, plus a lot of times this region also becomes, because their regulations are still catching up often with Europe or US, or even China for that matter. So it becomes a dumping ground for uh, 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 older models, if I may say so, right? So, and I'm not just talking about emissions, right? It also has repercussions in terms of overall vehicle safety, and the support that you would get from the OEM and so on. So, how do you see that as a challenge when you are looking at probably a third life, oftentimes, right? So there is a first life, maybe somewhere in Europe or Japan or Middle East. Then the vehicle is imported for its second use, and then retrofitment probably is looking at its third use. So how do you see that as a challenge in terms of the authorization process, plus in terms of what we talked about till now?
Yes, so firstly, I want to apologize. We currently experience the biggest problem with electric vehicles in South Africa, and that's our energy crisis. So we currently have load shedding, so the signal is very bad. But I think I've heard you correctly. So with third use vehicles, in Africa, I don't think it's a problem because currently we're already using the fifth cycle vehicles. People here are driving vehicles older than you can ever imagine, more beat up. You barely can't imagine that it's currently moving forward, but yet it is moving forward. From a retrofitting point of view, obviously those vehicles are not ideal to use. However, because we are going down to the chassis, so I think it's also important to note that there's a lot of components within these vehicles that can be easily replaced, and more so as the rest of the world is moving to newer electric vehicles, Africa will become one of the dumping grounds for all the second-hand vehicles coming from all around the world. So I think it doesn't. It's not. I almost want to say it's not a challenge for the retrofitting case. In fact, I think it adds to the retrofitting case because the electric drivetrain is a bolt-on system, or is so easy to implement within a chassis. Even if it is the third use, the third life cycle, you're still able to do it. You just need to ensure that the chassis is safe to drive, that there's not rust, there's no corrosion, that you still meet the safety standards and the test thereof. The manufacturer's warranty is already done by then. So you already have a vehicle that's technically zero rand if you look at from a zero in cost, if you look at it from a financial book perspective. So for you to sell it, it does almost not make sense. Yet in Africa, you won't be able to afford an electric vehicle of similar capacity or size. So the change is inevitable. The world is going to move to electric vehicles, and we as Africans need to find a solution in that which we are getting from the rest of the world, but also that which we can supply and already have, to use that in our benefit to make the transition happen, so that we can also as a continent benefit from this whole transition.
Great. Thanks, Stephen, for that insight. One last question we will take. We are nearly towards the closing time. But it's a very interesting question. It's a very small one, but very interesting. Uh, we often talk about standardization to tap into economies of scale. Applied to retrofit, how can that work? Because a lot of times there is some amount of, so we are looking at retrofitting as many vehicles as possible. Now you will encounter very different models. Yeah, model years also come in. We were working on one of the retrofit uh, proposals or projects where we were talking about, say, retrofitting the Bajaj RE. Now, Bajaj RE over last 10, 12 years also has seen lot of changes. So it's difficult to even say that this kit fits Bajaj RE across 10 years or 12 years, right? So how is it possible to leverage this standardization? Do you look at it that more or less this is the size of motor, or more or less this is a module of the motor which can be utilized, and then I can scale it up. Batteries are, I would say, relatively easier to scale up, probably if you go with a modular approach. But how does this sound in terms of the retrofitment, in the context of retrofitment, when we talk about standardization of components and subsystems to tap into economies of scale? I think Stephen has some network issue. He has dropped out, but Rani, if you could answer that question, your thoughts on it.
First of all, Vikrant, I don't know about the four-wheeler, because four-wheelers there are a lot of changes happens. But as far as the three-wheeler is concerned, I'll come back to you on from a three perspective. One, according to the AIS 123, any vehicle with a GVW plus or minus 10% is valid with the same certification. Number one. Number one. Number two, Bajaj RE, whatever the changes they made, they did not make changes to the CC engine capabilities or capacities or to it. Correct? They might have changed the seat on the back side or front side, or the 10 mm here and there within the thing. None of these changes will impact your your working or your conversion kit processes when it comes to the performance of it. Why am I saying is, these are all the things which are determines, what determines is the GVW of the vehicle determines your mileage or anything, and rest all here the features will not happen. So standardizing as far as a three-wheeler, that is why I always say the conversion of a three-wheeler is the easiest thing which you can do. Because in India, 65% or 87% is the market share by 67% is the market share of Bajaj. And Bajaj Piaggio Ape, if that GVW is more or less same, I think then that also works for them. Here, from the 2006 model to 2009 and 2011 model, the only difference you will see is a propeller shaft difference. Other than that, there's not much of differences, at least. See, today we have converted around 30 to 40 vehicles. We have seen some changes. We have to make some little adjustments with which will run. So I don't see that as a major, because that much change you will always observe in your own manufacturing, also in your own vehicle, day-to-day things. There will be a percentage of 5 to 6% variation. So this I don't see as far as the three-wheeler is concerned, Vikrant. And as I rightly said, it is not on the CC. The engine they have not changed. It is not that something. See, we are not talking about a seven-seater. We are not talking about the loader. So we are talking about the passenger vehicle. So that should hold good. Yeah.
Sure. I think Stephen, you are back. Just to wrap up, the question was about can we look at standardization in the context of retrofitment, particularly when you have a wide array of vehicles to be considered, even if you take one model and make, right? Because you may get it model year 2015, 2018, 2013. So how is it possible, first of all, to do a fair amount of standardization in terms of probably the major ones, the power modules, the battery modules, and the motors? Is it possible to do that? And what are your thoughts on it? Stephen, you are on mute if you are speaking.
Sorry, Vikrant. I think Ronnie must take that. I can't hear you guys properly, so I didn't even hear the question. Sorry for that.
No problem. I think it's on the four-wheeler.
No problem.
Yeah, I think four-wheeler, I'm sure the differences of, especially when it comes to the pickup truck, especially in India, as per the AS 123, the model is what they approve, Vikrant. And then apart from that, the GVW is what it counts.
Right. Sure. No worries, Stephen. I would really like to thank both of you for the very interesting insights into how to tackle a lot of challenges. Most of the challenges, as both of you confirmed, are actually non-technical. They are more perception. They are more, ecosystem or the adoption-based challenges. And really insightful discussion. Uh, Leveraging your actual experience, rather than talking hypothetical. So really great to hear all of that from both of you. Over to you, Yamini, if you want to close it officially.
Yes, yes. Thank you so much. I would like to close it officially, but I have a very small question related to capacity building. So one of our audience also said, so retrofitment is spoken about as a complex, a skill to, remove components from IC and fit into your other components like batteries. So I want you to clear that up. Is it a complex process? And then when it comes to skill, the manpower that you need for doing that. So what is that area where you need that kind of manpower? So I understand potential is high, we can do stuff, we can implement it, but then you would need people to do that. So if you can clear this space for us to understand, so I think that one last bit would be really helpful.
Excellent. Uh, it's a good question whoever has asked actually. See, India's three-wheeler is organizedly unorganized market when it comes to services. You have 4.8 crores of auto rickshaws flying right from Kashmir to Kanyakumari. Now, who are all servicing this? Every nook and corner you see an auto mechanic. How do you define their skill sets? So their skill sets, if tomorrow we have to do a retrofitment centers, we are not going to do. They are the people who are going to do with the training. So fitting and then servicing an engine is more complicated than removing it. First, number one. Number two, electric motor fitment is a easiest thing which to their skill sets. I'm telling. See, skill is a very subjective matter. You can't say. See, for a doctor, removing an engine would be a tough, but for a for a mechanic it would be an easy, right? So if I to answer your question, I am benchmarking the people of current auto mechanics. Okay, today from from this 6s to this thing, whatever the transition has happened from the electronic to the old vehicles, all these mechanics are smart enough to upgrade themselves. So tomorrow, in fact, this is also one more point, that they shouldn't think that their livelihood has been taken off. We are converting them the existing auto mechanics, saying that hum bhi electric karte hain, kind of a concept, and driving this force to the rural areas as well as in urban areas, saying that existing auto mechanics can also do this conversion kit with a little bit of training. And we also have a very comprehensive file system, like a typical IKEA, where the step 1, step 2, step 3, step 4, which needs to be followed. And we are also conducting some training programs, and then time and again we do that. In order to answer you in one liner, it is not at all a difficult task for the existing auto mechanics, for sure.
Got it. Excellent. Excellent. I
We
think
yeah, as a country, especially like when I say in with the Indian perspective, that's where we have to leverage, so that their livelihood has not been taken care. Because if anything happens to the other than the vehicle, he will only go to that mechanic, right? So he can't go to two people.
right, right. Absolutely. I think this has been amazing, and when it comes to job, I think the scenario will be same with Africa, and maybe for Africa, we need to start from scratch for EV retrofitment, to some extent even train them, and it's always, I mean, it will always be a good thing to train people and upskill whenever they're open and leveraging them. Very interesting. I think overall the webinar has been a good insight, and I think we would like to have you both again sometime doing a in-depth level on retrofitment, trying to talk in a deeper aspects. But thank you so much for giving your time today, and thank you, Vikrant, for your time. We look forward to engaging more with everyone, and to all the attendees, thank you so much for joining. Thank you very
Thanks.
much.
Thanks so much. Bye.
Thank you all. Take care.